Hello and welcome to Aorb Talk. Today we are very excited to announce another course which is NumPy. In this course we learn basic to advanced NumPy and we will divide it into multiple section of this course. So this video is basically introduction video and to understand what is NumPy, and then we will see some basics of NumPy. After that we'll move to a practical part of NumPy. So let's start with the outline. So agenda of today session, first we will see the introduction. After that we will see the founder of NumPy. After that we will see how we use NumPy array, why not array in Python. After that we'll see how to install and import NumPy, a bit example we'll see there. Then we'll understand what prerequisites you needed to learn NumPy, and in the last we will see outline of this NumPy where we will cover in the future video of this course. So if we see the introduction to NumPy, if we go with the name num, which mean numerical, and py mean Python. So NumPy is numerical Python library that we used to solve math calculation, for example number, array, or any math functions. Second, it's very fast comparative to Python because it's built in C language. And if we see, it's make us easier to do a math operation on large data set. For example, if we adding a number in the array of more than 1 million, and if you compare with the NumPy, and NumPy is much more easier and much more faster to handle large number of data set. If we talk about founder of NumPy was created in 2015 by Travis Oliphant, around 20 years back, because right now I'm recording the video in August 2025. In almost 20 years this NumPy was created, and it's used in every matter of machine learning, data science, or GenAI even. So because when we're feeding the data into machine learning models, first you create your data into NumPy array, and then you're using this array for them for future prediction that we'll talk later on the courses. What he did, he basically combined older library called numeric with NumPy array and made NumPy. Because of this conversion, it make more powerful, simple, and easy to use. And today NumPy is maintained by the open source community. Why use NumPy? Well, it's work faster than Python list. For example, if you compare to store 1 million elements in the list of Python and compare with NumPy array, NumPy will be much more faster to store and doing operation instead of Python list. Why? Because it's built in C language. If we see the second point, it's used in AI, data science, and machine learning. Why? Because in a real world we have a raw data, and for that first we convert raw data into a meaningful data, and then we're feeding into machine learning, deep learning, and GenAI models. So before we are using NumPy to convert those data into a proper format, and then we're feeding to the model for future prediction. Again, it's easy to handle large array and matrix. Now we will see how to install and use NumPy. To simply install NumPy, simply we use NumPy Python package manager. Simply install, and whatever package you want to install, you have to give the name. For example, I wanted to install NumPy because I wanted to use NumPy, and simply pip install NumPy. As I already installed NumPy, so you will see. For example, I'm using here VS Code, so I'm using pip install NumPy, and if you're using Conda, you simply have to use Conda install NumPy. As I mentioned that I already installed, that's why I don't need to further install. What version I'm using, as you can see, I'm using the latest versions 2.3.2, and right now I'm recording the video in 19th of August 2025. Now we'll use NumPy. To use a NumPy, first we need to import our package, which is NumPy. So import NumPy, and I simply run it. So I already install, and now I imported it. Now I have to use. So now we'll see a basic example. We already installed NumPy. So let's create an array with NumPy. So let's say that a is equal to our array np dot NumPy dot array, and I just create two number, and I just print it. So as you can see, we create our first NumPy array with two elements inside the array. So that's how you can use NumPy. Just wanted to show you one more quick example here. You don't need to use NumPy every time. You can give a different name. For example, NumPy as NP, and instead of using every time a big name here, so just simply use NP and then run it. So this is another way you can give any name. Mostly people follow the name of NP, numeric, and Python. So that's how you can use NumPy. This is just for demo purpose. In a future video we will briefly explain all the basics to advanced NumPy. Now let's move to the next section. What prerequisites need to learn NumPy? Simply you need to know Python. If you know the basic of Python, you can easily understand how to use NumPy. We already made a complete course of the Python. If you didn't check out, first check out this course. We covered all the basics to advance in this course. So learn this course first, and then you can move forward with the NumPy. If you're already good with Python skill, then you simply start with NumPy. What we will cover in this course: first we try to learn how we can create a simple 1D and 2D matrix. After that we'll try to create 1, 0 and empty matrix with different operations that we will use in NumPy and function as well. Then we will see a various mathematical operation in our third tutorial. After that we'll move forward with the mathematical operation. Then we will do a brief tutorial on slicing, and then we'll see a different function that we will use to handle concatenations and split. And after that we'll see some trigonometry, for example sine, cos and tan, we can use with different values. Then we'll see a random sampling, where we'll create multiple random values with different matrix. And in the last we will see how we can use NumPy in string with various operations. For the source code you can follow this link, and I will also paste in the YouTube description as well. You can check out this link, and where you can find the GitHub repository and all the video detail as well.
Hello everybody, and welcome to the second episode in the Aorb Tech NumPy series. Today we're going to be talking about arrays, including one-dimensional arrays and two-dimensional arrays. So let's get started. In this episode we're going to be learning what arrays are, how to create your first one-dimensional array and your first second-dimensional array, all using NumPy. So what are arrays? Well, arrays first and foremost are data structures. That means that they are a method of storing data or information within a computer. Arrays are static, meaning that they take up a certain amount of space in memory in the computer, and they don't change size throughout the runtime of the program. That means that once you create an array, it will have that number of elements for the rest of the runtime of the program. Arrays are also mutable. This means that you can change the values of the data inside of the arrays during the runtime of the program. And finally, arrays are ordered. This means that each element in the array has its own index that you can use to access that element in the array. Arrays differ from lists in the way that they take up less memory in your RAM, in your storage, and they are faster to look up. That means that when you search for an element in an array, it's going to take far shorter of a time to search for it than it would in a list. other than the differences mentioned prior. So let's get into creating your first array using NumPy. First of all, we have to import NumPy. So we can do that by simply importing NumPy as such. And now we can use NumPy in our code. Let's go to this first section here. How do we create an array using NumPy? Well, first we have to define a variable here. And we're going to say that we're going to use NumPy here. And we're going to use the array function. And the array function is going to allow us to make an array. Let's say we put some random numbers in here. It doesn't matter really what we put in here. It could be anything. And as soon as we do that, let's see what is inside of this array, what it's going to look like when we print it. As you can see, all of the elements that we put inside when we define the array can be accessed and seen as a string as such. Now let's say we want to see what kind of data type this is. Well, if we use the type function on our array variable, it returns that it is a NumPy ND array. ND array, what this is basically, this means that it's an n-dimensional array. This can be 1, 2, 3, or any dimension basically. And we'll see what that means a little bit later. And this tells us also that it comes from NumPy. So this specific data type is one defined by NumPy, and it's one that we can use to create all these different types of arrays. Now, let's see the dimensionality of this array. Now, what is a dimensionality? Well, dimensionality essentially is, as we were talking before about n-dimensional arrays, one-dimensional, two-dimensional arrays, essentially it's the number of indentations you have in the arrays. Think about it kind of like a 1D plane, a 2D plane, and a 3D plane. The number of axes that you have is an interesting way to look at this. You can see them kind of like a matrix, or like a three-dimensional matrix, for example. And in that way, it makes it a little bit easier to kind of visualize how an array looks like. So we can access the dimensionality of an array by using NDIM. And this will tell us the dimensionality of the array. And as you can see, because we created a 1D array, it simply returns 1. Now, let's see how we can get the size of this array. So, what we do here is we array and size. We print that, and we get 5. What this tells us is the number of elements inside of the array. As you can see here, we have 5 different elements: 10, 122, 76, 28, and 4. Another thing we can do is we can check the array's data type using NumPy. And we can do this by using dtype after array. What this tells us is basically the data type that's being stored inside of the array. Arrays can only have one data type that they store inside, as opposed to other data structures which might allow you to have multiple data types like strings, integers, characters, booleans, etc. Well, arrays can only have one of those. So how to create two-dimensional arrays, and for that matter, what even is a two-dimensional array? A two-dimensional array basically is, in the easiest form to think about it, an array within an array, and you can kind of expand that, so you have an array within an array within an array within an array, and that'll be a four-dimensional array, for example. But for this episode, we're just going to focus on up to 2 dimensions. And creating it is pretty simple. It's very similar to creating a 1D array. What we do is we create an array, let's call it array underscore 2D, and we're going to say it's equal to, then we're going to use NumPy, and we're going to use the array function, and within this array function we're going to create a pair of brackets, and inside that we're going to create another pair of brackets. So this is kind of an array, and inside that array there's another array, and we're going to use a comma to create the second part, which is here. And this is the kind of array within an array, and then the second array within that array. So there's an array that can have multiple arrays inside it, and I can't think of another situation where I have to say the word array so many times. So inside these arrays, we can put our own little values like 12, 13, 14, for example. Here we can have some more values, 15, 16, 17. And it's important to note you cannot place values inside here. You can't put like 12, you can just put other arrays. So if we just print this, we'll see what it looks like kind of. And what you can do is you can add even more of them. So let's say we want to carry it on 18, 19, 20, and now you have a sort of 3 by 3 kind of area. That's another interesting way of looking at it. You can look at it kind of like as a grid of elements, right? So this would be on the first row, this would be the second row, and this would be kind of the third row, and each of these is like a third of each column, depending on how many different arrays you have inside of this one. You can even add a fourth one, but an important thing to note is that you can only have the same number of elements inside of each of them. You can't create one with like a single element. For example, let's just add 10 here, and you'll see we get an error, so that wouldn't work. Now let's say we want to see the shape of this one, so I'll go to, and this is where the shape property becomes useful. As you can see, what this basically shows us is, like I was saying before, you can describe this as a kind of 3 by 3 grid, right? And that's literally what this is telling us here. It's saying 3 by 3, right? Which is really cool. So if you had something like a 2 by 3, let's say we remove one of these here, run that, and now let's see the shape, and you can see it's a 2 by 3 grid, which is really, really, really cool. Let's check the data type. Maybe it's changed. Maybe it's, as you can remember, the first one was an ND array. So if we check it using the type function, did it change types? No, it's still an ND array. And basically you can substitute any number in there. So long as it's non-negative, you can't have a negatively sized array. This would be like a 2D array basically. So now let's see what kind of data type is inside here. As you can see, we have integer 64. That's the kind of data type that's inside of this array. So in here you can see we have 12, 13, 14, 15, 16. Those are all integers. And this is the same as the previous data type, which if we go up to this array here, as you can see, it has all of these numbers here. These are all numbers basically. And now if we want to check the dimensionality, so as we said, this is a 2D array. So if we go here and we put NDIM, that's the n dimensionality, we'll see it gives us a 2. So we confirm that it's a 2D array. And that's basically all you really need to know about the basics of creating 1D and 2D arrays and arrays in general.
Hello and welcome to Aorb. Today we're going to start another session about NumPy, and this session is all about to create a different matrix. So the agenda of today's session, first we'll learn how we can create a zero matrix. After that we try to learn one matrix, and in the last we'll see how we can create a empty matrix. So let's start with it. Before going to start zero matrix, first, as you know, that we need to import our package, which is NumPy, as we already know that NumPy is used for multi-dimensional array. So let's import NumPy as NP. You can give it any name, but standard one that mostly people use are NP. Now let's create a zero matrix. So I wanted to give a name, let's say that zero matrix 1, and to create a zero matrix you need to define your package, for example NP, then you have to write the name, for example which matrix you want to create. For example, I wanted to create a 0, so I press 0, and then how many row and column. For example, I wanted to create 3 row and 4 column, close bracket, and I just wanted to define, and as you can see that we create our first zero matrix with the 3 row and 4 column. As you can see, by default, if you see, these are the float. So let me show you zero matrix dot d type. As you can see that by default it's float. So let's say that I wanted to create another matrix, zero matrix, this one, to give the name of 2 np dot 0, and this time let's say that I wanted to create a matrix of 4 by 7, and I want to call, and let's see the result. So as you can see that I create another 0 matrix with the 4 row and the 7 column. As I mentioned that by default it's a float value, but if you want to change the name, if you want to change the data type, you can simply maybe I can show you here. So let me copy this example again, and I need to dtype, and I would say that integer, and I just run, and as you can see that now my 0 matrix with the 4 row and 7 column are integers. You can check the type of the matrix, for example dot type, and it will show you integer 64. So as you can see that you can create a 0 matrix with a different data type. For example, here I can create integers. You also can create a boolean or some other data type as well. So I hope you understand. Simply you just need to write the package dot and just call a function of the package, for example 0, and whatever length of the matrix you want to create, you just defined the value. For example, the first parameter here is represented by row, the second is represented by the column, and if you want to change the data type, then you need to pass another parameter, and you have to mention which data type you want to create with the 0 matrix. So yeah, that's how we can create a 0 matrix. So let's move to our next topic, how we can create a 1 matrix. Now we will learn how we can create a 1 matrix. To create a 1 matrix, let me show you. So 1 matrix, and I just call my package, and simply you have to call once, which means 1 matrix, and then you have to call how many row and column you want to create. For example, I want to create 6 row and 4 column, and let's run 1 matrix with 6 row and 4 column, and as you can see that our 1 matrix is create here. Very easy and simple way, same as that you create a 0. Instead of write 0, you just simply have to write ones. So by default it's again boolean. Let me show you an example, and let me show you how we can change the data type as well. So let's say that 1 matrix data type, and as you can see that is float, and let me show you another example, and I would say that matrix, and I wanted to create another matrix once, and I would say that 2 row and 2 column, and simply I just need to run my code, and as you can see that 2 row and 2 integers with the 1 matrix. If you want to change the data type, for example, you can simply change the data type, for example integer, and if you want to check again the data type is changed or not, so simply you need to run the function dtype, and it will show you your data type. So as you can see that is integer. For example, this time I wanted to change another data type, and I would say that instead of integer I would call as a boolean. So let's see. It's great. Let me check the type, as you can see that it's true. Why is true? Because our value inside the matrix is 1. If it's 0 in the above case, it will show all value are false, but here in this example, as you can see, true, because all the value are 1, as you know, that represented by true, and 0 is represented by false. So that's how you can create one matrix with a different data type. If you want to check the type just to make sure, so simply you just need to run the function dtype and it will tell you the type, which is Boolean. So perfect. As you know that this is the same way you can create a matrix of 1, same as you create a previously in a 0 matrix. Perfect. That's how you can create a one matrix. Now let's move to our next topic, which is create an empty matrix. So let me show you how we can create an empty matrix, which is our last topic today's session. So to create empty matrix, let me define a variable name. Let me say that empty matrix, and I would say that call my package and it's empty, and then I would take 4 row and 4 column, and simply I just to call my variable and I will get my results. So these are the empty matrix that we create. As you can see that we create with 4 row and 4 column. Maybe the question came to your mind, why this looks so strange here? Although we create empty matrix, but why this value? So when you create an empty matrix, it does not set any values. These are just random values. Main point is that this empty matrix is created based on the shape here. So 4 row 4 column we created here, value are not set. These value are just random value which assigned to this memory allocator based on the shape that we given. I hope it's clear for you. So let me show you another example. Let me take a different column and row, and if we say that empty matrix 1, and if we call, and as you can see that these are again a random value that we assign here, and it's allocated based on the memory that we gave here, for example 5 row and 5 column. And if you wanted to check simply the data type, it will show float, and you can change data type as well, as I mentioned. So if you want to check the type, and I wanted to check, maybe let's say that bool value, and just simply it will return, it could be true, it could be false, because it's a random generated value allocated to memory. It does not set any value, it just basically allocated a memory based on the shape. So yeah, that's it for today. I hope this session is clear for you. If you have any questions, feel free to write in the comment section. And let me repeat quickly what we learned today. So we learn how we can create a different matrix. First we learn to create a 0 matrix. Simply call the package, and after that 0 and whatever value or you want to create, for example 0, 1 are empty based on your choice and which shape you want to create. I also show you can change the data type as well. For example, we change here integer, and lastly we clear with empty matrix. As you can see, this is a random value generated based on the shape that we given. And yeah, that's it for today.
Hello everybody, and welcome to the fourth installment in the Aorb Tech NumPy series. Today we're going to be looking at NumPy functions. Today we're going to be looking through the arrange function, the linspace function, the reshape function, the ravel function, the flatten function, and the transpose function. Let's start by importing NumPy, which we can do by using a code block, and then just running that. First we're going to be looking at the arrange function. What this function basically does is it creates an array Similarly to the range function, we have the start, stop, and jump parameters, and it's going to create an array for us with all of those numbers that would be visited during the range function. So let's use an example with the variable array. Let's use the numpy.arrange function. Then we're going to say we want an array with numbers between 1 and 10, and we want to step by 2, and then we're going to print that array. And let's see what that looks like. So as you can see, it's printed all the odd numbers between 1 and 10. Let's do another example with the numbers from 1 to 100. Let's say array is equal to numpy.arrange, and we want the numbers 1 to 100. Since we want to include 100, we're going to put 101, and we're going to leave the step size so we have every single number. And then let's just print and see what that looks like. And we should get every number from 1 to 100. And there we go. That's every number. You can count them if you want. Might take you a while. What the linspace function allows us to do is it allows us to create a certain number of equally spaced elements between a start and ending point within an array. Let's test that out. Let's create an array here, and let's say it's equal to numpy, and we want to use the linspace function between the values 10 and 100. And we want to space them 10 apart. So then this should give us all of the 10s between 10 and 100. And let's see what that looks like. If we print it first. And there we go. We got all those numbers. Let's say we want to visit some decimal values between the numbers 1 and 3. So we can create another variable. Let's call it decimal this time. And let's say it's equal to numpy dot, and then let's use the linspace function. We put 1, 3, and let's say we want to check 10 different spaces between them. Then we'll print decimal, which is our variable, and we'll see what it looks like. As you can see, it visits every point between 1 and 3, making sure that there are 10 elements, including 1 and 3. That's important. It includes the first and the last number. So keep that in mind, because sometimes you might expect a different result than you get. Let's talk about the reshape function. In previous episodes, we discussed the shape of an array, specifically a multidimensional array, which basically tells us the structure of a multidimensional array and what it looks like. The reshape function allows us to take an array and, if possible, change its shape or rearrange its elements to create a new array that has a completely different shape. It's important to note that the number of elements stays the same. What you're changing is basically the arrangement of those elements. So, for example, you could have a single array with 12 elements inside it. You can use the reshape function to then create a multidimensional array with 2 arrays inside that each have 6 elements. Now, since there are 2 arrays and each have 6 inside, that's 2 multiplied by 6, which adds up to 12, our original number of elements in the original array. So that's how the reshape function works. Let's test it out. Let's start by creating an array. We'll use the arrange function, and we'll create a list of elements ranging from 1 to 21. And let's print it just to see what we're looking at. And that's what we're working with. Now, let's create another variable, array2. And we're going to use the reshape function on our first array. Here is where you have to use your math skills, specifically division, very simple division. We know that in 20 numbers, if, say, we wanted to divide it amongst 4 different arrays, there would be 5 elements inside each array. So we can use the shape 4, 5. And let's print it just to see what that looks like. As you can see here, we now have 4 arrays, each with 5 elements inside. Let's try doing something a little bit more complicated. First, let's create an array. Let's use the arrange function, and we'll create an array with 27 elements inside, ranging from 1 to 27, and then we're going to print it just so we can see what that looks like. And here we go. We have the numbers ranging from 1 to 27. If you know much about maths, you'll know that 27 is 3 cubed, which means that its factors are 3 multiplied by 3 multiplied by 3. We can use this fact to create a new array. We'll call it array 3. And we'll say that it's equal to the result of applying the reshape function to our array that we created. We'll use 3, 3, 3. And what this should create is an array with 3 arrays inside, which each have 3 arrays, which each have 3 elements. And so let's see if our theory is correct. Let's print it. Oh, we need to print array 3. And here we go. We have an external array. This has 3 arrays inside. And each of these arrays has 3 separate arrays. And each of those arrays has 3 separate elements inside of them. So that's pretty cool. You can do some pretty complicated and complex stuff using this function. The next two functions, ravel and flatten, are both very similar. They differ in one key way. However, their main goal and function is identical. What they essentially try to do is reduce a multidimensional array and its elements into a single dimensional array. The key difference between these two being that ravel returns a view of the original array whenever possible, and flatten will always return a copy of the original array. For the sake of demonstration, we'll be using array 3, the variable that we created in the previous demonstration. So let's go down and create a code block. What we're going to do is we're going to print the result of using the function ravel on our array 3 variable. And let's see what that looks like. As you can see, we get a list of elements here, and they are all in a single array, as opposed to this amalgamation here of 3 arrays inside 3 arrays inside an array. Now let's go to flatten and see if it does something similar. We'll apply this function to it and print it. As you can see, it does basically the same thing. Just keep these two differences in mind when you're using these functions in your own code. The final function we'll be taking a look at is the transpose function. If you've ever done a course on linear algebra, or if you've dealt with operations on matrices, you'll know how this works. The gist of it is that we swap the columns and rows, or the elements according by the columns and rows, in a matrix or in a multidimensional array. To see what that looks like, we're going to have to make a demonstration. Let's start by creating a code block. Inside it, we're going to create a matrix. We're going to call it matrix. First off, we're going to use the NumPy .arrange function. We're going to create the values from 1 to 9. That means 10, non-inclusive. And then we're going to reshape that into a 3 by 3 matrix. Then we're going to print it just to see what that looks like. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 different rows and 3 different columns all going down. So we have 1, 4, 7, 2, 5, 8, and 3, 6, 9. So what do I mean by swapping the elements between their respective columns and rows? Well, it's important to note that the elements that are going down the diagonal from the first element, the very first element on the top left, will stay the same because their columns and rows are exactly the same. But elements which are on opposite sides will swap. For example, 2 and 4 will swap. 2 is at the position of the first row and the second column, and likewise 4, or opposite-wise, is in the first column and the second row. So these two elements will swap. These two elements are opposite, and they will also swap, 3 and 7. The same goes for 6 and 8. So let's try and use the transpose function to create a matrix, which is a transposition of our original matrix. This is something that you'll find very common in linear algebra and in matrix operations. So it's very cool to see it in code. Let's say that we're going to create a variable, and it's going to be called transposed matrix. And it's going to be equal to the result of applying the transpose function on our matrix variable. Make sure we spell that correctly. And now we're going to print that new variable and see what it looks like. As you can see, it is exactly as we described. The 4 and the 2 haven't swapped. The 7 and the 3 have swapped, and so have the 6 and the 8. And most importantly, the numbers going down the diagonal have stayed exactly the same.
Hello and welcome to Aorb Talk. This is another session about NumPy series, and in this session we will discuss mathematical operations. So the agenda of today's session: first we'll discuss additions, after that we will discuss subtract, then division, after that we will discuss sum, and then we will discuss mean, and finally we'll discuss square root, exponent and logarithm. So let's start with it. Okay, let's jump into practical session. As we know that we are working on NumPy series. For that we need to import our package. So we already upload our package here. Import NumPy as NP. Now we'll work on various mathematical operations. So first we'll start with the definition. Mathematical operation, if I explain in a simple word, you basically apply a various operation using NumPy. NumPy, we have a function, a various function where we can use them and apply on different matrix and array. So, and there is a various operation we will discuss one by one here. So let's start to create our first matrix. After that we will apply on various operation on that one. So let's start with the code and let's start our first create our first matrix. So let's say I wanted to create a matrix np dot range function, and I wanted to say that I wanted to create 12 element in this array. So if I print it simply, and as you can see that this is our first array, but we need to change the reshape because we wanted to apply operations on matrix. So I just reshape 3 by 4 and let's run, and we get our 3 row and 4 column results. This topic we already discussed very briefly in the previous sessions, so if you didn't understand, go and check out. Just a quick demo. First we create our array here 1 to 12, and based on those elements we create our matrix. So you cannot create any matrix, but based on element you decide how many a column or row you want. For example, I said that 1 to 12, it could be 6 or 2 combination, or 3 or 4 combination, or 12 one combination. So that's how we can create, and this is our first matrix. Now we need another matrix for using different operations. So let's say I take another column, and then I would range, and I said that I am taking, instead of 1 to 5, I'm taking, like, let's say 13 to 25 further, and then I reshape with the 3 and 1 again, and I would just call the B and run, and we get our results. So perfect, we will use these two matrix for those operations. So simply we just create our first matrix with the 3 row and 4 columns. Same for the second as well. The elements start from the first matrix 1 to 12, and the second one start from 13 to 24 onward. Perfect. So let's start with the addition. Addition, as you know, that this is basically you adding a two value. So for example, a is equal to 5, b is equal to 3, 5 plus 3 is equal to 8. So that's how it works. So there's a two way to use addition. One way is basically you simply add a plus b, and if I run, you get the results. Simply positions is important. For example, one column, first row, and then second column, first row, third column, third row, third column, first row versus third column, first row. So that's how, for example, we get 113, 14, then 2 plus 14, 16 plus 3 plus 15, 18. So that's how it works. But we are working on NumPy series, so this is just for demo purpose, but our actual purpose is to use NumPy to do those operations. So I would say that I will call my NumPy function, then I would say that add, and I will just call a comma b, and I will run it, and I will get the results. So that's how you can use NumPy and apply those operations. So I hope it's clear for you. Next we'll see a subtract, same way, and we'll not use those simple operations here because our purpose is to use NumPy and to see how we can apply those operations. So for the subtract we just need np dot subtract b, and then we'll run, and we get all the results here, minus 12. Why? Because this is, if we see our array 1 and array 2, basically we are subtract, so basically 1 minus 13 will be 12, 2 minus 12, 14 will be 12, so we'll get the negative results because our second array has a bigger value than the first one. So I hope it's clear for you. Now we'll see multiplications. So for multiplication we simply use np dot multiply, and then simply you got a b, and I would just simply call and you simply multiply here. So how it's multiply here, let me call my first array quickly here so you can visible the results as well. So let's me call the b as well. So how we get this result? So 13 multiplied by 1, 13, 14 multiplied by 2, 28, 15 multiplied by 3, 64. But as you see that these multiplication are based on the position. For example, same way that we did additions and and subtract. For example, first column, first row, first like element will multiply with the first one, the second with the second, third with the third, fourth with the fourth, and so on. But what if we need to multiply row versus column? Like if we see in linear algebra we multiplying with the row or column, how we can do that? You simply run np, instead of you write multiplication you simply write dot, and then you simply call a b, and I run, and I get results which is shape is not aligned with the line. Well, as you know that when we are doing dot multiplication in matrix, your the first one, which is basically a here, a column should be equal to the row, but here in this example our results is not equal because it's showing me the dimension issues. So first we need to apply a transport maybe, So and then I will multiply it. So how transpose is work here? It basically, if I call this one T and simply, you see the magic? I will show you again. So basically these are basically 3 multiplied by 4, but if I transpose it, it will reshape 4 to 3. So row become columns and column become rows. That's how it works. So now if we see our shape, our column is equal to row, so we can easily multiplication. So 1, 13 and so on. So that's how you applying a dot operation here. The next one is division. So for the division we just simply call same np dot, and then I have to check divide here, and then I just simply take a b, and if I run I will get my results. Why we all the values get in zeros? Let me do opposite way, it's more complex. What here, because 1 is basically divide by 13, then 2 divided by 14, so it's will be 0 0.002 something. So if I take b as a first and then a as a second, so which mean b divided by a, which means 13 divided by 1 will be 13, 14 divided by 2 will be 7. So let's see with this way, and I'm quickly just copy this line and paste another cell, and I'll, instead of taking BA to give a quick demo, I take this example, and as you can see that, so we got 13, then 14 divided by 2 will be 5, and then so on, so on, so on. So that's how it's work. Now we will see here we are mostly playing with two matrices. For example, we're doing addition, subtraction, multiplication, and then we'll see two way to do a multiplication. One is start, and then we see a division, and now we'll see a sum. So let me call my a. And what is sum? Sum is basically to sum up of all the values. So np dot sum, and if I run, it will give me my results. So if we add all those value, you will get 78 results. So if we take the mean, same, you simply add np dot mean, and then simply you just say, and this is we get 6.5. How mean is work? You know that you have to add all of those value and divided by the number of element which is represent here. So how many represent here is 12, and then also sqr, which is square dot sqr, simply I'll take square, and then I will take a, and then if I run, we basically a square of the value. So 1 2 square of 4, 3 square of 9, 4 square of 16, and so on. So, and there's another way which is basically a square root. So quickly I will add here t, run, and now I'll take my another cell of code. So same way, let me call my first a, because and now I will do sqr square root, and what I will do here, simply you have to type np dot sqrt, and I will take a, and if I run I'll get my result. So 1 square root will be 1, 2 square root will be 1.4, and 3 will be 1.7, and so on so on. So that's how sqrt is work. Exponent, now we'll take the exponent is basically np dot, simply you have to call exp, and then you simply just run and you will get the exponent value. So one exponent will be 2.7, then 2 will be 7.3, 3 will be 2.0, 4 will be 5.4, and so on. And the last one that we will see here is basically a logarithm. So logarithm is basically simply take the logs of those respective values. So I will select log a, and I think I am on the markdown. So let me quickly change to NumPy, and if I run log a, and I will get my result. So that's how logarithm is work. Now there's a few things in the last we want to discuss. One is basically a max operation, and the last one is basically a min operation. So let's start with the max. So max is basically, I'll show you the example. Let me take my, just recall my array that we gave first. So if I show you how we can use max, so simply you have to call np dot max, and you just call a. So what will happen, it will give you the maximum value, which is 12. So if I wanted to see the arg max, and let me show you the importance of the argmax. So argmax is basically tell us the index positions. So simply, as you can see that now we'll move forward to our few example with the max and min. And in max and min we basically check our maximum and minimum value. So simply I'll take my code cell and I will show you quickly. Let me run my a matrix, which will already create. I'm going with the same example, and let me see np dot max, and I would simply take a, and what we get here is basically 12. It will show us the maximum value of 12. So same if I take for the minimum, even np dot min, and I will go with the minimum, and I will get the results of minimum, which is, as we already know, that it will tell us the one is minimum in this current matrix that we call here. So perfect, that's the end of this session.
Hello everybody, and welcome to the 6th installment in the Aorb Tech NumPy series. Today we're going to be looking at array slicing. In today's episode, we're going to be covering row slicing, column slicing, diagonal slicing, and item size. So let's get right into it. So let's start, as always, by importing NumPy. We can do that by using import, entering NumPy, and running that block of code. There we go. Let's start with row slicing. In NumPy, row slicing has a very simple syntax, which is quite similar to that used in the Python syntax when we are using slicing on strings and lists. When we're using row slicing in arrays, we'll start by using an array, and then we'll use a pair of square brackets. Inside we'll have the start, followed by a colon, the end, followed by another colon, and the step size. What the start tells us is the index at which we wish to start slicing. From that point onwards, we will carry on to the next element until we reach the end of the array, or until we reach the end size, which will not be included in the slice. That means that if I were to access from the 0th element to the first element, only the 0th element would be accessed. Finally, the step size tells us by how many elements we move each time that we go to the next index when we're slicing. In layman's terms, if I wanted to skip one element between each other element, I would use a step size of 2 because it accesses every second element. Now that we have this syntax, let's see how it works using some code. First, let's create an array. We'll call it array, and we'll use the arrange function to create an array from the first element to the 10th element. We'll print it to see what we're working with. So we have an array with 10 elements inside. Now, let's create another code block, and inside that code block, we're going to do some slicing. So let's create a new variable called slice. And we're going to say slice is equal to our array element. Then we're going to use the square brackets that we talked about earlier, and we're going to access from the first element, or the 0th element. Then we're going to put a colon, and we want to access up to the 5th element. So that should give us the first 5 elements in the array. And now let's print that to see what it looks like. And as you can see, we get the first 5, from 1 to 5. Now, let's create another block of code. Let's create another slice, and this time we're going to call it slice underscore even. We're going to say it's equal to our array variable, and then we're going to slice that array. So we only want to access the even elements of our array. We know that this element 1 is at the 0th position. So we don't want to include that. We want to start from the 2nd position, which means we're going to be using the index of 1. Then, we don't want to have an end position. We want to access every element in the array. So we're going to skip this part and we're going to add another colon. Then, finally, we're going to use a step size of 2. So we skip every other element. And then, we're going to print our new variable, slice even. As you can see, it returns every even element in our array of 10 elements. If we wanted to reverse this, there's a very simple way to do that using string slicing. We'll print our array. Using the square brackets, we'll create a slice. We want to access every element, so we'll skip the first part. The interesting part is when we use the step size. We'll put in a -1. This means that each time we'll move backwards from the last element to the first element. And now let's print what this looks like. And remember that these 2 colons, since we're not putting anything between them, means that we're accessing the entire array. And the only thing that we're changing is the step size. So let's see what that looks like. And as you can see, we have the same array as before, except that the elements are in reverse order. Column slicing has a very similar syntax, except that we place a colon after the row slice to access the column slice. If you wanted to access a further dimension, you would need to place another colon, and so on, until you reach the desired number of dimensions. To demonstrate this, let's create a code block. First, we're going to create a matrix. We'll use the NumPy arrange function, and we'll create elements from 1 to 25. Then we're going to use the reshape function. And we're going to put those into 5 arrays with 5 elements each. Then we're going to print our matrix to see what that looks like. As you can see, we have elements from 1 ranging to 25. Let's start by doing something very simple. Let's say I wanted to access this column here from 3 to 23, including 8, 13, and 18. Let's create a code block. We're going to access our matrix by printing it. Then we're going to use a pair of brackets. Inside we're going to skip using the row because we want to use all the rows, so we can just put a column. Or what we can also do is we can put a 0 and then a colon, and that'll access every element in the array. You can also just put a colon. And then what we're going to do is we're going to access the column at the second index. So this would be the column at the 0th index, the first index, and the second index. So now let's see what that looks like. As you can see, it doesn't quite print them horizontally, but it does print the correct elements. So we have 3, 8, 13, 18, and 23, and as you can see, that's the third column from the left. Okay, now let's say I wanted to access all of the middle columns. So that's from 2 to 4 and from 22 to 24. So all of these numbers in the middle here as well. What we're going to do is we're going to print our matrix. Again, we're going to use the square brackets. Inside those, we're going to skip the rows section. We're not going to meddle with that yet. Then we're going to put in from the first index to the fourth index, not including the fourth index, and we'll see what we get. As you can see, we get 2, 3, 4, 22, 23, 24, and that's exactly the same as we have here. Let's say I wanted to access every second element. What I would do is print the matrix, use the square brackets, skip the row slicing, and now what we can do is, let's say we start from the 0th element, so we want to include 1, 3, and 5, and we skip the ones in the middle. All we have to do is change the step size to 2, and let's see what we get. 1, 3, 5. Let's also just really quickly cover some row and column slicing at the same time. Now you can kind of think of it as which row do I want to access, and inside each of those rows, which of the elements do I want to access. So let's say I wanted to access every second row, so that'll be 1, 11, and 21. So this row here, and this row here. And inside each of those rows, I want to access only the even elements. So that'll be 2, 4, 12, 14, 22, and 24. So what we can do is we can access our matrix. Again, let's print the result so we can see what we're doing. Now, we're going to access both the row and the column slicing. So as we said, we want to access every second row. So what we're going to do is we're only going to change the step size. Inside each of those rows, we only want to access the even elements. So we're going to start from the second element, or in the first index element, you could say. We're not going to change anything else. The end, we don't want to change the end. And we want to skip every second element. And so let's see what we get. So there are only even elements, and they are the ones that we want to access. So from every second row. And there you go. Okay, let's tackle diagonal slicing now. It's a little bit more difficult, but the theory is kind of similar. Instead of using square brackets, though, we will be using a diag function provided by NumPy. Inside, we're going to use a k variable, and we'll place, obviously, our matrix inside as well. And the k variable, you can kind of think of it as like which diagonal do you want to access, and we'll kind of see that visually now. So first, let's start off by creating our matrix. We'll use the arrange function from 1 to 100. We're going to reshape. We're going to put them into 10 elements, 10 arrays, and let's print it just to see what we're working with. So we have a matrix here with elements from 1 to 100. Now, if we wanted to access this main diagonal here, so that's 1, 12, 23, 34, 45, 56, 67, 78, 89, and 100, what we would have to do, let's first create a code block, is print, since we want to actually check what we're going to do, and then we're going to use the NumPy dot diag function. Inside, we're going to use our matrix, so we're using the matrix as one of the arguments of the function. And inside that, we're also going to say k equals 0. It should always default to 0, but just for the sake of demonstration, we're going to put it here. So that means it will start from the 0, the element position 0, 0, if you want to think of it like that. So let's print it and see what we get. So you can see it accesses all of these elements here. Let's really quickly do the same thing. So let's copy this. Let's place it in, and let's change k to 1 and just see what changes. So as you can see now, it's accessing this diagonal over here. So that's 2, 13, 24, 35, 46. You can kind of think of it as moving up by 1 in the matrix. So if we were to change it to 2, it would access from 3 to 4, from 4 to 5, and etc. until we get to the top of the matrix. And let's do one more. Let's try doing a negative k and see what happens. What we'll probably assume would happen is that it would start from 11, 22, 33, so on until it reaches 99. Let's see if that's correct, if our hypothesis is right. And as you can see, that's exactly what it does. So it's actually quite a simple thing. It looks a little bit scarier because we don't use the brackets. We use a function, but it's actually quite simple, and it's quite cool and useful. And finally, we're going to be looking at item size. And what this tells us basically is the number of bytes that each element in an array or matrix takes up. So let's use our matrix that we created earlier, so this variable here, which we called matrix, to make things extra easy. And it should tell us here how many bytes it takes up. So, and that's 8. Okay, so let's really quickly check what that means. Well, let's see what kind of data type each element is being stored as in our matrix. And that's int 64, which means that it's taking up 64 bits, right? So we know that a byte is 8 bits. Let's divide 64 by 8 to see how many bytes each element is taking up. As you can see, we get an 8. So this property here was correct.
Hello and welcome to WebTech. This is another session about NumPy, and in this session we will briefly discuss concatenation and split. So the agenda of today, the first we will discuss concatenate, and then we will see a various method, for example vertically or horizontally, and the same way we will see how we can split our data. So let's start with it. Now let's start with the practical demo. Before going to start, we already know that we need to import a package. So I already upload package here, import numpy as np. Now let's start with concatenate, and if I see the definition, basically in concatenate you are basically joining two array or matrix together into one bigger array or matrix. So let me show you with the example. Let's take our first matrix. I would say that np dot range, I would take maybe 5 element with the shape of 2 by 2. We already know how the shape is work, and let's run. So what I did here, I just create array or 1 2 4 element, 5 already is excluded and we already know, and then I change the shape from array to matrix, which is 2 column and 2 array. So simply we have one, and then quickly with the same example, and I will create a B, maybe with the element start from 5 to 9, and if I run, I get my second matrix. So now we'll concatenate it and let's see how it's work. So let's concatenate by column. Now we'll see how we can create concatenate by column. So simply I take array, let's say that, give the name of array, and then I numpy dot concatenate, and I would simply don't need access, I just run my matrix, and as we know that this is merge by column, so 1 2 3 4, and then we have 5 6 7 8. So this is how we can concatenate by columns. So by default access is 0 here. So this is by concatenated by column. You can use another way to concatenate by columns. So let me show you how you can do that. So simply you have to say that array, and let's say array 1, and I want to np dot v stack, and I just simply run, and it will work the same. So v stack is basically being vertically stack, so vertically merge two different matrices. So this is how it's work. I hope it's clear for you. We learn in this example concatenate by columns. So simply I take two example. I create, for example, a matrix of 2 by 2 and b matrix of 2 by 2, and in np.concatenate, simply you just call your matrix, and it will join and become a bigger matrix here. So as you can see, now the length is 4 by 2, 4 rows and 2 columns. The same here as well, 4 rows and 2 columns. So it's basically vertical stacked here. So this is how you can concatenate by columns. I will show you how you can concatenate by rows as well. To do that, you have to use same. Let's say I will take example row 3, and I say that nb dot concatenate, and I have to mention the axis. Axis 0 by default is vertically, and axis 1 is by default is horizontally. So if I run my tree, and if I show you, and as you can see that it's joined. So now you have 4 column and 2 array. So this is how you can concatenate your rows as well. And if I show you by the example of stack, so simply you just, let's say I will take array 4 and np dot h stack, and if I run, it will give me the same result. So as you can see that. So I hope it clear for you. In this example we learn how we concatenate by columns and by row. So simply either you change the access method and use the same function in NumPy concatenate, or either don't use access, or simply use the function of vstack and hstack. So I hope it's clear for you. Now we'll see split. Split, if I explain a very simple word, split is basically opposite of concatenate. In concatenate we are basically merge or join two array or matrix, but in split we are basically divide array into a smaller parts. So let me show you with practical. Let me take array, and let's say that I want to take np.range, and I say that I want to take 1 to 12 element. If I print, as you can see that we take 1 to 12 element in this array. So now let's use a split. Let me show you the example. So np dot split. So let's say that I wanted to split into two parts. So how it will split here? So if I take a and I wanted to split into two parts, so simply you have to write 2, and it will give a 2 array 1 to 6 and 7 to 12. So as you can see, we get 2 array. First array we start from 1 to 6, second is start from 7 to 12. Let's say that I wanted to take split basically into 3 or 4. So if I want to take 3, I can take 3 as well. So basically split into 3, so 1 to 4, 5 to 8, and 9 to 12. If I say that I want to take into 6 part, that's also possible. So we take 2 element in each row. But if I show you another example to explain how the split is work, so if I wanted to split it 5, well, it will not split, does not result in equal divisions. Why? Because our array is 1 to 12, and if we split into 5 we cannot, because it's not properly divided. So if I want to split, make sure it's properly combination. So let's say that I want to split 2, yes, it's possible. We'll make a combination of 6 6. If I wanted to 3, well, it's possible. Combination of 4 4. If I wanted to split of for example 6, yes, it's possible. Combination of 2 2. But if I want to take a 5, well, 5 split from here, 5 split from here, but this is not properly split. That's why we get this error. So I hope you understand how the split is work. So that was the end of this session.
Hello everybody and welcome to the 8th installment in the Aorb Tech NumPy course. Today we're going to be talking about trigonometry. In today's episode we're going to be covering some helpful functions, trigonometric functions, and inverse functions. And as always we'll start by importing NumPy, so let's just do that. And of course run that block of code. First of all, we're going to be looking at the helpful functions, and these functions really are helpful because especially for some of them, we're going to be using them throughout the rest of this episode, especially when dealing with trigonometric functions and inverse functions, so basically everything. Starting with the deg2rad function. This function is very useful, probably the most useful function in this episode. Essentially what it does is it converts from the unit known as degrees to the unit known as radians. Now, degrees, most of you will know, are a way of representing angles, like 90 degrees, 180 degrees, 360 degrees, and so on. Radians are simply another way of representing angles using a special kind of unit. They are based in the pi constant, and they're used widely across mathematics. And they are also used in our trigonometric functions, which is why we're going to need this function for this episode. So to see what this function does, let's really quickly put down a block of code. We can use the numpy dot deg2rad function, and we'll put in 90 degrees, and if we print this we can see what the radian equivalent of 90 degrees looks like. Let's run that, and as you can see we get 1.57 and so on, a bunch of numbers basically. Rad to deg essentially does the exact opposite. So just to test out if this works, because we could put in any number and it would still be kind of confusing, let's try and do the inverse of this number over here and see if it gets kind of close to 90 degrees. What we can do is we can literally copy this number over here, then we can use the numpy dot rad to deg function, and we can input our number in there and see if it's like kind of close to 90 degrees. So let's print that out. Oh, and yeah, we actually get exactly 90 degrees. So yeah, there you go. And finally, we're going to be looking at pi, and this one's kind of self-explanatory. It just returns the pi constant, which not only is a very extremely important number in mathematics, but is even more useful in trigonometry. So let's really quickly print out our numpy dot pi, and then we'll just kind of print that out, and you can see we have the constant here. I mean, it's not the full constant, but you have about as accurate as you can represent it for most purposes. Let's move on to trigonometric functions. Now, these are nothing special. They're about the same as those you'd find on your scientific calculator. If you've ever used one in uni or high school, you know what I'm talking about. And basically, they're just a way of taking an angle and kind of giving you a number that represents it as a sort of ratio. Again, they work in degrees. So we're going to be using our degree to radian function that we discussed earlier to help us use these functions. To test this out, let's start by creating an array. We're going to call it degrees. We're going to use the arrange function, and we're going to visit every 15 degrees from 0 to 180. And so we're going to use a step by 15, or step size of 15, visit every 15 degrees, and let's print it out just to see what we're looking at. There we go. And now let's create another array called radians. And it's going to be essentially a conversion from degrees to radians. So that means we're going to need to go up and use the degree to radian function from earlier. So numpy.deg to rad. And then we're going to input our degrees array. Now let's print that just so we can see what it looks like. It's going to be a bunch of crazy numbers. It doesn't make too much sense. Although, as you can see, we have pi at the very end, 3.1415, etc. And this is because radians are essentially stored using pi. In fact, the exact ratio is pi divided by 180. So if you use 180, if you multiply by that, you'll get pi. Now we're just going to go through each of these trigonometric functions one by one, starting with sine. So for sine, we need to use numpy.sine. And what we want to do is we want to visit every single one of these that we have in our radian array, our radians array. So we're going to do a for loop. We're going to create a new variable called radian. And we're going to access them from the radians array. And we're going to print the result of using the sine function, the numpy.sine function, on the radian. So let's go through that one more time in case it's a little confusing. What we're doing is we're creating a for loop. This is going to access each of these elements in this array one by one, so each of these values here, and it's going to run them through the sine function. And then we're going to print that result to see what it looks like. Now, if you remember anything from your trigonometry class, this sine function starts from 0, it kind of goes up like a wave, and then it goes back down once it reaches 180 degrees. So if we print it, we should expect values starting from 0, going up to 1, and then slowly going back down to 0. So let's see what it looks like. And as you can see, we get a number 0, slowly goes up to 1, and then it goes all the way down basically to 0, although I think there's been some kind of floating point error here, because we've got a number that's very, 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 very extremely close to 0, but not quite. So that's just a limitation with computers in general. But next we're going to be doing the cosine function. So let's just copy this for loop here. In fact, let's copy this entire code block here. We're basically going to do the exact same thing, except we're going to use the numpy cosine function. And basically this is going to do exactly the same thing. It's going to apply each of these values inside of the cosine function. So now we're going to see what values we get. Now, if you remember from trigonometry, again, the cosine starts at the top, so it starts at 1, then it goes down to 0, somewhere around 90 degrees, and then it reaches sort of its lowest point at 180 degrees, so somewhere around -1. Let's see if that's what we get here. As you can see, we started from 1, we end up somewhere around, or very close to 0, near the middle, and then we, at the end, approach -1, or reach -1. Finally, let's apply this to the tan function. So let's just change this function here to tan. And again, this does the same thing as we've been doing for the other two functions. It applies all of these radian values that we converted from our degrees. So these degrees here, because again, these functions use radians instead of degrees. And then we get the values. So the tan function kind of goes like in a kind of, you can imagine it as going all the way from -infinity up, creating a sort of saddle, and then going up to positive infinity. So the values we get here should be can be a little bit strange, but we'll see what it looks like, and hopefully it checks out. And at 0, 0, we have a sort of gentle slope going up, becomes an extreme slope going up. So we start at 0, slowly increasing our values until we reach ever so closer to infinity, and then we start from the negatives. So we start going up, approaching 0, and then going up again from the left to the right. And as you can see, that's somewhat what we get. We could make this more accurate by using a smaller amount of degrees, a smaller spacing between each of the degrees. Instead of every 15 degrees, we could check every 5 degrees, for example. But just for the case of this demonstration, we're going to be looking at every 15 degrees. And as you can see, this works perfectly fine. But remember to always convert from degrees to radians first before applying them to this function. Finally, we're going to be looking at the inverse functions. The inverse functions literally do the exact opposite as the trigonometric functions we looked at earlier. So the sine, the cosine, and the tan functions. These are represented by arcsine, arccos, and arctan. Essentially what these do is they take one of these numbers, for example, and they convert them back into degrees, or in this case, radians. So let's start off with arcsine. So let's create a block of code here, and we're going to print the result. What we're going to do is, first of all, we're going to use NumPy, and then we're going to convert the radians that this function gives us to degrees, just so it makes it a little bit easier for us to tell what we're talking about. So now, we're going to use the numpy.arcsine function, and if we go up here, remember that for sine, 90 degrees, which was somewhere in the middle here, there it is equal to 1. So if we input 1, we should get the opposite, and then we should get 90 degrees as we're converting the radians that this function gives us into degrees. And as you see, we get 90. Now if we don't use this function here, rad2deg, it'll just give us the same value that we would have gotten over here, if we can look at it. This value somewhere in the middle here, which represents 90 degrees in radians. It's, I think, somewhere one of these values here, 2.35 or 2.09. So if we print it, we'll see what we get. 1.57. Okay, so we were a little bit off. 1.57, that's this value here. So this value represents 90 degrees in radians. So the reason we used that function earlier, if we put it back, is we're converting from this number back to degrees. So let's do that one last time. As you can see, we get 90 degrees. We can do the same thing with arccos. So let's print. Let's put in our numpy dot arccos, and then we'll convert it into degrees afterwards. So let's just see what number we get. So if we put in 0, let's see what number we get this time. Let's try 0. We get 1.57. That should be 90 degrees, because remember, the cosine function, it starts at 90 degrees. So now let's use the numpy dot rad2deg, so radians to degrees, and we should get 90 degrees hopefully. 1.57, as we can remember from the previous example, gave us 90, so hopefully that's what we get. And there we go, we get 90 degrees. Perfect. Let's try something like 1. Now, this should represent 90 degrees. What we should get is 0, because cosine goes down to 0 by 90 degrees and it starts going below the flat line, or the y position of 0 once it reaches that point. So we should get 0. There we go. And let's move on to arctan. So again, very similar thing. What we're going to do is we're going to print. Let's do numpy, and let's just directly convert it to degrees, so rad2deg. And then let's put in the numpy dot arctan function. And let's put in 90 degrees, see what we get. 45. Let's put in a number like 0, see what we get. It should be 0. There we go. Let's put in something like 270. See what we get. We get 89 degrees. So you can play around with these. You can use these for your code if you want to use something in your project that has trigonometric functions. The inverse functions are useful as well. And of course you have the pi constant, the degrees to radians and backwards conversions. And I think they're quite useful. And that's it for this episode.
Hello and welcome to Aorb Tech. This is another session about NumPy series, and this session we will discuss random sampling. So the agenda of today session, first we will see how random.random is work. We'll generate some different random values. It basically create a different float value. Then we'll generate some integers value using rand int function using NumPy. After that we will see a seed function is in NumPy, and we will see how we can use seed. And second last we will see how we can choose a different value from the given array, and last we'll see how we can change a random order of a given array. So let's start with it. So before going to start, as we know that we need to import our package, and the package is import numpy as np. Let quickly run. So it will take some time. So let's start with random sampling. If I see the basic definition, random sampling is basically you create a random value, and this random value don't have any order. You can create any random value in a list, array, or maybe a different matrix of a different random value. So let's start with random.random function in NumPy. Let's say I wanted to take a and I wanted to create a value mp dot random, and I will pass a value. For example, I wanted to create 4 random value. Random will give us a 4 value, and if I show you here, and as you can see that we create a 4 random value. This random value will start from 0 to 1, so, and it will create any random value. So if I copy, and I will create maybe this time 8, I'll give a different name, for example, and yeah, as you can see that we create 8 random value. So if you want to create a random value, instead of this is array, basically you create, if you want to create in a matrix, I'll create a matrix. Let's say that I want to create np dot again random, and then you will take another parenthesis and you pass a value. So I pass a value 2 row and 3 column. If I print, you get the results, and this results is contain 2 rows and 3 column. The values 0 to 1, and it's any random value. So let me show you another example maybe, and I will say that 1, and I said that I will take, for example, 5 and 9, which means that I'm creating 5 rows and 9 column, and it will generate the value based on those dimension that I mentioned here. So very simple, you just use the function after importing the NumPy package random.random, and it will generate a value from 0 to 1, and how many values you want to create, you simply pass the values. Either you want to create array, you simply pass any one value, or if you want to create a matrix, then you pass another parenthesis and pass the dimension. The first dimension will be like rows, and the second one will be column. So I hope this will be clear. Now I'll move forward to the next topic. Now we will see random.random function, how you can use in NumPy. So if I explain, random dot rand int is basically create a integers value. Previously we using random dot random, we create a float value. The value start from 0 to 1, and now you will see how we can create an integers value. So let me take, let's say that I will take x, and I say that np dot random dot rand int, and if I pass the value, when I say that I wanted to take maybe 4 value, and if I run x, you will see that 3. Why? Because we provide a range here. So previously we just provide how many values you wanted to create, and here you basically provide the range. So from 0 to 3 it will create any random integers value 1. And if I say that I wanted to take the value between 1 to 100, and if I run, it will generate any one value based on this range 1 to 100. So this is how rand int is work. Let me show you another example. If I say that I wanted to take 1 to 11, for example 7 to 11, or if I print, take another variable instead of going the same one, x. So if I run, it will give one value, any random value started from 7 to 11. So if you want to create a matrix, and let me show you how we can pick a matrix, and b dot random, sorry, spell issue, random dot rand int, and I say that I take 1 to 100 range value, create 3 rows and 4 column. So if I print, you will see the magic. We create a random matrix here. The range values, any random value started from 1 to 100, and the dimension, I mean the matrix, is like 3 rows and 4 column. So let me show you another example quickly, and I said that I'll take 3, and I said that I take started from 120 to maybe 101, and it will create 5 column and 5 row. If I print, you will get the results 5 by 5 matrix, and the value is started from 101 to 120, any random values. So that's how a random dot rand int function is working in NumPy. Simply just passing a range of the value, it will give any random values. So I hope it's clear for you. Now we'll move forward to the next topic. Now we will see how we can use random dot seed function, and for example, random dot seed is used when we want to create a random value but constant random value. Let me show you with example. Let's say that I take this function, and for example I take, instead of matrix, I just pass the range for to 10, and if I pass m4, I change the name as well, it will create any random value started from 4 to 10. So if I this function run, it will create a different value. If I run it again, it will create again different value. If I run it again, it will create another different value. So if I copy the whole line of code and I paste, and if I want to run this time, you will see a different value as you see previously. So why we use random seed? What's the purpose? So if I use random dot random seed and you just pass any value, just random value just take, and for example I say that np dot random dot seed, and I pass for example value, and if I run again and again, you will see a constant value, but here it will be different value. But by using random dot seed function, you simply generate a random value but a constant random value. So for example, if I copy this command and if I run again, sorry, I need to go to the next line. If I run it again, now you'll see we get 8, and if I run it again multiple times, we'll get the same results. That's how our random dot seed function is work. Maybe questions came into your mind that why you pass this 0 value, why not some other values? Yes, you definitely pass another value as well. I just pass a 0 value. This 0 value will create a random value, a constant random value when I run on next time. But if you change the a number of seed here, it will create a different random value, and it will link with this seed. So every seeds has their own constant random variables. So you can take any number, and for example I take this example, and let me show you the quick example. If I pass 42, so it will not give me the results of it will give me a different random integers results 7. So if I run this command again and I will give a different name, it will give me the same results. So seed values, it depends to create a random constant value. So this was a different random values and this was different random constant values. So I hope this will help to understand how random dot seed function is work. Now we will see how random dot choice is work. Random dot choice is basically you basically select any random value. So how it will work, let's say that I take array and I set that any random value 1 2 2 4, maybe not to repeat, 3 5 7 4 9 and 10 maybe. So now we'll use nb dot random dot choice, and if I run, it will select any random value from the above array that we create. So yeah, as you can see that it's make a choice of 7 element from this array. So that's how a random dot choice is work. Maybe you play a game while guessing a random value, so you create a function 1 to 10, and then you basically guessing so how many times you were correct. So that's the same way you can create the game. And if I run this again, and it will give me a different results, maybe a same one as well happen. So if I run it again, it will make a different choice. This time it make a choice of 2. Last time I will try and it will make a choice of 3. So as you can see, start from 9, then 2, then 3, and so on and so on. So that's how a random dart choices work. So let's start with the next topic, which is our last topic of today's session. Now we'll see how the random dot permutation is work. So let me take any array, for example, and I say that 1 4 7 6 8, and random dot permutation is basically changing the order of a given array. So let me show you how it's work. If I say that np dot random dot permutation, if I pass the value of x and if I run, you will see the results. As you can see, the order is changed. So in choice we see random dot choices basically select any random value from the given array, but random dot permutation is basically change the order randomly of the respected array that we passed here. So if I copy this line, then if I run it again, you get a different results. So if I try one more time, and you see different results. So that's how random dot permutation is work. So that's the end of today's session.
Hello everybody and welcome to the final installment in the Aorb Tech NumPy series. Today we're going to be taking a look at string operations. Today we're going to cover add, lower, upper, capitalize, center, join, replace, split, split lines, title, equal, not equal, and find. And we're going to start off as always by importing NumPy. So let's create a code block, import NumPy, and run that. There we go. So let's quickly create our string variables. First is going to be intro, and we're going to make it welcome to. And then we're going to create another variable, which is going to be name. It's going to be Aorb Tech. There we go. Starting with add. Let's create a code block here, and we're going to use NumPy dot char, standing for character, and then we're going to use add. Let me just correct that NumPy really quick. Inside this, we're going to put two custom strings, hello and world. And let's see what we get when we run that. As you can see, we get this over here, and this is our NumPy string. Now let's create another code block, and let's use our variables from before. Those are up here, intro and name. So, once again, NumPy dot char for character and dot add, and within that we're going to put intro and name. And let's see what we get. What we should expect is a NumPy string, and then enclosed within that we should have welcome to Aorb Tech all together. And there we go. We have welcome to Aorb Tech. Let's take a look at lower. What this does is it takes our string and it converts each of the characters into their lowercase counterparts. If the characters are already lowercase, then they remain that way. Let's demonstrate this by using a code block to first print our name variable that we created earlier. As you can see, both the A and the T are uppercase. Now, to convert the entire string, that is all of the characters inside the string, to lowercase, all we have to use is NumPy dot char for character, and then dot lower, and then we plug in our string variable, our name variable, and we'll see what we'll get. As you can see, we have an array of characters, which is essentially what a string is, and this is the text within Aorb tech, with the A and T being lowercase. Upper essentially does the exact opposite. That is, it takes all of the characters in the string, and if they are lowercase, converts them into uppercase. And the uppercase characters remain the same. So let's really quickly print out our name variable once more just to see what it looks like. And note that every single character except for A and T are lowercase. So that's E, C, H, and O, R, B. Now, to make this full caps or all capital, we're going to use NumPy dot character dot upper. Then we're going to put in our variable name, and let's see what we get. As you can see, we have a full caps version of this string right up here that we originally had. Now you might think that capitalize does the exact same thing as upper due to its name, but in fact it does not. What it does is it capitalizes a string as though it were a sentence. To demonstrate that, let's create an example string. And now we're going to use numpy dot character dot capitalize with a Z, and then we're going to plug in our example. And let's see what we get. Now, what we should expect is that the first letter, as it is a sentence, becomes capitalized. And as you can see, it's exactly what we get. Everything else stays the same, with a slight misspelling, of course. But as you can see, the H in hello is capitalized. Let's take a look at center, and what this does is it essentially creates a string of a certain size with our string placed in the middle of that string. To demonstrate what this looks like, let's really quickly use the numpy.char.center method. There we go. Let's put in our intro variable that we created earlier, and let's create a total size of 20. As you can see, there are empty spaces to the left and right of our string, with our string being in the middle. If you were to count all of the characters in this total string, it would be 20 characters overall. Another neat thing is you can also specify the character that is used to fill in the string. So in the default case, it's filled in with empty characters, but if we were to use the attribute with our previous parameters, if we were to use the attribute fill char, and we can put in our character, let's say for example we wanted to use the asterisk, we get the exact same string, but as you can see, asterisks are used in place of empty characters. Note that this empty character here was in the original string as well. Let's take a look at join. What this essentially does is it takes a string or an array of strings and places that in between the characters of another string or array of strings. And to demonstrate this, because it does sound a little bit complicated, we're going to take our name variable. Let's just print it out to see what it looks like once again. And now we're going to use the numpy.character.join function. We're going to create an array here with a empty space character, and we're going to use our name within an array as well. Keep that in mind. Variable. And so what this should do, what we should expect it to do, is place this character here, this string, in between the characters of this string here. So we should expect spaces between each letter, including a triple space in the middle. Let's see what we get. As you can see, that's what we get. Now note that there are no spaces or empty characters to either side of the entire string, only in between each of the characters. We can also demonstrate this with multiple strings. So, for example, if we wanted to use our intro string from earlier, we could also use the numpy.character.join function. And let's say for this one, we want there to be semicolons between each of them. And just for fun, let's also use our name variable, so we can do multiple at once. And we're also going to use the empty space, or just the space character. Now we're going to create another array here. And inside that, we're going to have our intro variable and our name variable. Now, what's actually going to happen here? So, first of all, what happened in the previous case when we had only one? Well, it took this character here, or this string here, and put it in between each of the characters, not including the outer edges, of this string here. Now we have two strings, and we have two strings here as well. So what's going to happen is this first string is going to apply to this string over here, this variable. So in the intro variable, which we declared earlier, it's going to place a colon between each of the characters. And it's going to place an empty space between each of the characters in the name variable. So let's really quickly print and see what we get. As you can see, we have our string from earlier, and we have a colon between each of the characters, including the spaces. And we also have our name variable with spaces between each of the characters as well. Let's take a look at replace. What it does is quite self-explanatory. It takes one string and replaces a string within it with another string. So let's demonstrate that by first creating a congregate string, which is going to be made up of our first two strings. Let's call it welcome. And we're going to make it be intro and then name. And let's print it as well, just so we can see what it looks like. So there's a new variable called welcome. So it takes our previous two variables that we created and adds them together. That's what it looks like. Let's create another code block. We use NumPy .character.replace. We want to use our welcome variable that we just created. And now is the fun stuff. We can replace the word welcome with, for example, the word subscribe. And so if we run this, let's see what we get. And instead of welcome to Aorb Tech, we get subscribe to Aorb Tech, which you should definitely do. Taking a look at split, what it does is it takes each of the words inside our string and creates a list with each of those words inside. So let's use our variable that we just created, our welcome variable. We'll use numpy.character.split, and we're going to apply this to our welcome variable. And let's see what this looks like. As you can see, we have a list with each of the words separated within. Now we're going to take a look at split lines. What it does is something very similar to split, except that instead of looking for the empty space characters, it looks for the new line characters. To demonstrate this, we're going to create a new example string. And within, we're going to place here, we're going to use the break line character is break line character, a break line character, string. Okay. And now we're going to use the numpy.character.split lines, and we're going to put in our example string. Let's see what we get. Here you go. As you can see, it has split this string by each of the split line characters instead of the empty line characters as it did here. Now let's say we want to capitalize the first letter of each word in our string. Let's really quickly create another example string. We're going to call it title, and it's going to be, this is a title. Now we're going to use the numpy.character.title. We're going to put in our title variable, and as you can see, each first letter is capitalized, including single character words, quote unquote, and there we go. Now let's take a look at equal. What this does is essentially it compares two strings and tells you if they are the same. Let's create a string called A. It's going to be equal to Eric. And we're going to create another string, B, which is equal to Amir. Oh. Now, let's use the numpy.character.equal function. We're going to plug in A and B. And note that because these two strings are not the same, they're different strings, they contain different values inside, what we should get is false. Let's see if that's the case. And that's what we get. Now let's say we create another string called C, and that's going to be equal to Amir. And now let's really quickly test it with the same function. So we're going to test B against C. Now notice that the value inside B is the same as the value inside C. So they're both Amir. Now we should get is true because they're both the same. They're both equal. And that's exactly what we get. Now let's take a look at not equal, which does exactly the opposite as equal. We're just going to really quickly print A, B, and C just to see what they look like. So we have Eric, Amir, and Amir. Now let's create another code block. We're going to use numpy.character.not equal. And we want to check if Eric and Amir are not equal. So we'll put an A and B. Here we go. Let's see if they're the same. And they are not the same, so we get true. It's basically the opposite of what we did here. Now really quickly, let's check if Amir and Amir are not the same. They should be the same, so we should get false. So let's use numpy.character.not equal. And we'll check B against C, and we should get false. As you can see, that's what we got, whereas here we got true. Now let's look at count. What this basically does is it takes one string and sees how many times that string appears in another string. So let's say we wanted to see how many times the letter A appeared in a sentence. Let's really quickly create a sentence variable. And we're going to say this sentence is false. And let's say we want to check how many times the letter S appears, which we know is 4 times. So we have S here, here, and here. That's 4 times. We'll use numpy.character.count. We'll put in our sentence variable, and we're going to check how many times the letter S appears. As you can see, it appears 4 times, which is exactly as many as we predicted. Finally, we have find. What this does is it tells us the index at which one string starts within another string. Let's really quickly take our welcome string from earlier. Let's print it. Let's see what it looks like. Welcome to Aorb Tech. Let's say we wanted to get the index of 2. So let's take numpy.character.find. We want to look inside our welcome string, and we want to check where 2 is. It tells us it's at index position 8. Now let's really quickly count from 0, being W. 1, 2, 3, 4, 5, 6, 7, 8. So that's the T, the first T, the TO, the first letter of our string that we're checking for. 2 appears at the 8th position, and we verified that just now. Okay, there you go. And that was the episode on string operations. If you guys liked that episode and you want to see stuff similar to this, make sure to check out our channel, to which you can subscribe. You can like this video if you'd like and leave some comments to create some engagement for us. Or if you have any questions for us about the code present. We'd also appreciate if you hit that bell icon because it notifies you every time we release a video. So if you are interested in these series, you'll get notified every time a new episode is out. If you're interested in other series, we also have lots of series having to do with data science and programming and all sorts of topics, so make sure to check out our channel. We also have a website and a GitHub link with all of the source code available from this episode and from this series, and probably from some other series too if you're interested. So if you want to go practice or check out the source code yourself and test it out and maybe do your own kind of experimentation, then, well, there you go. I hope you have a lovely day, and thank you for watching. Bye bye.